Hi, thanks everybody for joining the session. I know it's not always easy to join the session after the food, but breakfast is better than lunch, so I'm happy here today. Maybe a few words about our company. So our business is pretty simple. We are taking big stones, crushing them, and sell different products out of crushed stones. Mostly, previously we called Heidelberg Cement, and cement was the main product, but now we produce not only cement and not only in Germany, so not only in Heidelberg, so our company is pretty big. We have more than 50,000 of employees across the world. We presented in North American region, Asia Pacific, Europe, Africa, and so on. And that's one of results on this picture. One of the houses printed in Germany using our products. In headquarters in Heidelberg, we have a pretty big IT department, but we also have some hubs in other countries, in Bulgaria and Czech Republic, and some other countries. But from our headquarters, we are developing our custom software. We started with custom software development not so far ago, so about 6-7 years, and I joined Heidelberg Cement at that time as a lead platform architect with a goal to build API platform which will serve customer-facing products. And now ended up as head of platform engineering because the teams developing software have grown pretty fast, and our software also grown pretty fast, and our platform which we have built went just from the simple one cluster platform to, I can say, hosting platform where we can host not only one application but several applications. And the main goal for today's talk is to share our experience, how we went from manual deployments on a single cluster to current setup where our developers can create a new microservice and deploy up to production within 1 day. Some of them can achieve this even in 2 hours, who have more experience. Yeah, we're still not at the target where we want to be, but yeah, I think if you consider platform as a product, you will never achieve a final state because the product develops all the time. And here on the left side, it's like me, 5 years ago, manually deploying first microservices to our cluster. So, how we started? The first MVP, when I joined, we had a goal. We started working agile, but we had a deadline when we need to deliver MVP. And at that time, we had one backend team, 2 product teams, so mostly front-end focused, and 1 part-time DevOps engineer. And I was like leading the backend team, also playing the role of architect. In the beginning, our friends from infrastructure department, which is still different from our current software engineering department, they were experimenting a bit with Kubernetes and created the first clusters using OKD. It's open source version of OpenShift. And at that time, what we had every every deployment inside the OpenShift, also including databases, all the stateful stuff. MVP was successful, so we got attraction of our products. They start being used by our customers, and then we started growing. In 2020, it was a funny year, but we switched this year from dedicated kind of backend team and front-end team to cross-functional teams, and we had 4 product teams, and we got dedicated full-time DevOps engineer, and she was helping to set up the cluster stuff and all the additional services which you have seen in the first presentation. Like we started building some meat on the bone of a Kubernetes. At the end, we had 3 Kubernetes clusters in different production Kubernetes. Sorry, I'm mentioning here only production because we had also dev clusters and so on. So 3 Kubernetes clusters in production in 3 different regions in North America, Europe, and Asia Pacific region. We introduced traffic routing based on the location of a user. We had first deployment templates and the first automation, but still the process was pretty manual. Then in phase of 2021, 2022, we started growing much faster from the developers amount and products amount. So we had at that time about 7 cross-functional product teams and about 8 products which were using the same platform and deployed to the same setup. So here I am giving only overview, and we will go deeper in details a bit later. And then current state, we consider that at the end, suddenly we built a platform. And last year we started considering what we have built as a platform and treat it as a platform, as a product. In fact, it's not only one platform, but I will talk about this later. And yeah, we have also, it's not the end. So we have some plans for the future, and yeah, currently here is 10 plus. I think now, state of today, it's about 19 teams, 18 or 19 teams working. I already lost the count, who are deploying to our platforms. And there are like teams who are using the shared API hosting platform, and the teams who have the dedicated, completely dedicated setup, which is isolated and have separate products which are completely isolated. Plans for the future: develop the platform as a product further, introduce more self-service. We have already some self-service, but it's not yet at the stage where we see it. Yeah, and introduce also, currently we were working mostly with software developers, with software engineers who was deploying the customly developed software. And the focus was really on the developer experience. And as a future, we consider also provide possibility to host already third-party applications. We already host some of them, but we want to create a template where it will be easy to host third-party applications used by our colleagues from IT, from the whole world. So basically enable regional, now they are system engineers or system admins, it depends on the country, from the local ITs to be able to deploy almost every application which is ready to be deployed on cloud native. So basically, if it's possible to containerize and to split between workloads and the data storage, then our goal is to enable a team to deploy every such application. But now a bit of deep dive to the MVP version. So which requirements did we have in 2019? We had a front end, several web applications, one mobile application. We decided, or our application team said, okay, for us it's enough to have Nginx server where we can put static files just to the file system. We can build it as a Docker image during the build process, upload everything to the Kubernetes and let it go somehow. For backend, it was a bit more requirements because from the beginning we had a requirement already decided by enterprise architects that we would like to have a microservices architecture. It's not always the best way to start with microservices when you start a green project, but for us it was from one side, it's a green project, but it was like third iteration of, or third attempt to build a global application and not go back to the local application which suits for North America but doesn't suit for Europe, or very good for Europe but doesn't work for Australia, and so on. So that's why from the beginning we had this requirement to have a microservices architecture. It should be connected to the internal network, to our on-prem data centers. And from the beginning, we were discussing an easy way to deploy for developers, and that's one of the reasons why we started with OKD, or OpenShift, you can say, because even 5 years ago, for simple use cases, it was enough to have OpenShift to deploy manually by developers. Then some requirements about backend. So basically, we had at that time Node.js and .NET. And when we are speaking .NET, it's .NET Core, so not the Windows deployable, but Dockerized, Linux-based deployments. And we had also from the development team some requirements to desired storage level. So we wanted to have MongoDB as a high availability cluster, PostgreSQL, RabbitMQ for communication between microservices, and for observability, yeah, it was enough to have logs, basic infrastructure metrics to understand is service died already or it's still alive, and exception gathering for front end and for the back end. So that's, I found some picture from a high level of architecture, what we had on backends. So yeah, here you have 4 different applications. From the beginning, we started creating microservices in different buckets. So basically that was green ones, the microservices which provide the business value. Blue, light blue, it's our deployments, as I said, Nginx containers running with built-in applications. And then we have some help services, some additional services which are not providing the main value, business value, but already start and building kind of development platform, so providing the SMS and email functionality in a standardized way, so you were able to push message to the queue, like fire and forget, and it somehow will come to the to the customer. Later we added, of course, some synchronous communication, but that was the state of 2019. Stuff which was delivered at the end of the year. It was delivered to the Europe and North America, but everything was deployed on one cluster in Europe. Here I tried to gather it using very nice template for platform teams from platformengineering.org. It allows really to structure your thinking, how you build a platform. So in the beginning, we have a pretty simple setup. So you can see that from the runtime, it's also OKD was used as a service catalog, workloads, compute, OKD, then Postgres, some Azure DNS we used from the beginning, and RabbitMQ also deployed inside the Kubernetes. We started with basic logs gathering and using EFK stack. At that time, it was still open source, Elastic. And from the beginning, we thought about correlation of our microservices and front-end applications, so that we will be able to understand the end-to-end picture, what happens when some user clicks on the button. So application performance monitoring tools, and in our case it was application insights. It allows from the beginning to have a pretty good picture of what's happening. It's not so expensive when we are speaking about metrics. Now you can put the logs there as well, but logs, it's a different story. It was expensive from the beginning. And from the beginning, we started using Azure Key Vaults and some synchronization with Kubernetes secrets, and Kubernetes secrets were consumed by microservices. The whole CI pipeline basically was done in GitLab CI, and it was classical integration and deployment. So it's a pipeline. Each microservice had its own pipeline and was able to be deployed independently. In the beginning, the process was manual, like, okay, we have a release of all services or all the application once in 2 weeks. Basically, main limitation is a business, because the business used to have user acceptance tests. So the time before the product goes to the customer, our colleagues from business want to touch themselves, test, go through the test execution plans, and understand that, okay, new feature delivered in the way how we want it. And then first time it was very valuable. But it was also one more requirements for us to support several environments from the beginning. So due to our complexity of our architecture, maybe going back. So here you see only the top of the iceberg. Because here on the integration level, that are interfaces to old big ERP systems. In some cases, it was through additional middleware, like here, or through direct access to web services provided by SAP through NetWeaver Gateway. And this part really had already from the beginning QA environment, UAT environment, production environment, and for some cases, since our applications were including also telematics, I mean, you have a truck, and our application allows, or we have a truck, you order our concrete batch, and in the application you can see where is a beton mixer coming, so that you can prepare your team to start pouring. Sorry, and for this business, for me as IT person, it was completely unknown that it's very critical to start pouring exactly in the time, because your concrete have some period of time when it has a best quality, and after that time, either the quality is not so good and you need to add water, or you need to spend more time to pour it, or it's completely out of quality standards. So that's why we had pretty a lot of environments, and some environments also emulating connection to the real tracks. So on UAT environment, it was one of UAT environments was connected to the production telematics data. Yeah, that was an MVP. Then the next step for us was a multi-cluster. I found original picture from one of the slides from that time. So basically, we had manually deployed OpenShift or OKD clusters in 3 regions, and they didn't communicate it through the cloud. They did communicate it through connections to our data centers and the global network between data centers. So it was not the best, but our idea was that in each cluster we deploy the same set of services, and in most cases, these microservices, when they are talking to backends, to the ERPs, they need to communicate only locally. Only in some cases, we had a global databases located in Europe, and only in some cases you have to access the global databases. But from the beginning, on application level, we had always caching possibility, so that it's easier to decrease the latency. So here we see some extension. We introduced pretty early SonarQube, which helps to keep good quality of our software. Not all the teams started using it from the beginning, but some of them started integrating to the pipelines, doing first experiments there. Yeah, basically, we started also using the biggest difference is the Azure Traffic Manager. So we are completely hosted on the Azure. But at that time, it was like OKD clusters deployed manually on virtual machines which were manually provisioned in Azure. So the process to deploy new cluster, let's say for new region, it took about 2 months because of all of communication you need to do within infrastructure teams. You need to approve all the firewalls, you need to deploy isolated machine, then your colleagues from infrastructure team don't have a time to deploy, and so on. At that time, we started growing as well in parallel. Number of services started growing. So I think in 2021 we had already about 100 deployments with about 70 services. And that's the high-level architecture at that time. So in each cluster we had an API gateway, and then from the mobile or web application there was connection to the Azure Traffic Manager, and based on it, based on the user location, it was redirected to specific cluster and specific region. So here we also started using much more services. At that time, we have realized that we had about 2 or 3 DevOps engineers, and it was not enough to support the clusters to handle properly stateful clusters. Because as soon as you start hosting your database inside the cluster, you need to think about your backups, restores, logical backups. One team wants backup of this database today, another want to restore from production to quality tomorrow, and it's really at that time during deployment to the OKD, the heaviest part was keeping up with growing data in the databases to scale manually the disks up so that they are working well. At that point, we decided, okay, now we started doing only stateless clusters for running workload, and having all the stateful stateful applications, if possible, provided as a service, platform as a service from the Azure. But we had some catches. So as I said, we have started using caching, and at that time we also used Redis inside the Kubernetes, and it was pretty fast, pretty good, all good. When we started using Redis as a service from Azure, we have realized that the latency became, so it already was not a cache. Sometimes it was faster to go to the database than to read from the cache. I don't know what was the reason. Was it the configuration of our network or configuration of the Redis services? And it was also pretty expensive. And we said, okay, for such services which stateful but short-term stateful, let's keep them only on Kubernetes, and the rest let's go to the Azure. So we had also some challenges during the growth phase. One of the biggest was too many services to deploy on too many environments. You have 100 microservices. Half of them are released in one day by 1 or 2 developers, and they need to go to a lot of environments. And at the beginning, we went to simple steps, and it was not parallelized. So you need to wait until it goes to Europe, North America, Australia, and that for each service, some display may not work, and it was too much. Then another complexity is too many different technologies and infrastructure products which were used. It was a challenge rather for DevOps engineers, because for one person you need to know how your GitLab CI working. At the same time, you need to know what's happening right now in signups, why it doesn't work, why data pipeline doesn't work. We also had a lot of non-technical challenges, like a lot of ad hoc requests coming to the DevOps team. At that time, DevOps team was already about 9 engineers. But since it was growing together with product teams, they have a friend, they go to the friend in the chat and saying, okay, let me deploy my service faster, let update my stuff without the planning and so on. And also knowledge silos within DevOps team was not allowing to, like, one person more familiar with signups, another with GitLab pipelines, and it was not possible to switch. And our decision was to switch to more standardized approach, and that's basically our current state. I hope it's visible on the screen. So currently, at the end, we got, as one platform, several sub-platforms. So we have a developers platform, basically the part which delivers developer experience. We have 3 types of hosting. So it's API hosting platform where majority of microservices are hosted. Then we have hosting for development tools, and we have application hosting template. So that's what we started doing. I will show a bit later if we have time. So basically it's a small template which has all the parts of the application. So front-end, back-end, databases, and whatever. Then we have observability platform. About it I talked last year in ContainerDays. So if you're interested, you can find the talk. Then we have a set of software building blocks, API management platform, data sharing, and identity and access management for external customers. So that's how it looks right now for us. Yeah, you don't need to photo if you want. I can share slides afterwards. So that's our current setup. A lot of time for DevOps engineers is observability part, because it's really challenging. Then we had a DevSecOps journey last year. I talked about it previously in Hamburg this year. So also pretty interesting journey. And yeah, that's how it looks like for the developer. And yeah, here is, I don't think we have a lot of time. So maybe a few words about this. So that's a template which I said. So we have specified the way how to deploy the applications, or how we prefer developers to develop the application, so that will be easy to deploy in pretty short time. So it's focused on the Kubernetes deployment for workloads with several APIs hiding behind the API gateway. They have inside the cluster for communication Redis and RabbitMQ. I think I forgot here to put the NATs, but we want to get rid of it. And we have some possibilities to deploy additional resources in dedicated resource group, or even in dedicated subscription. with services provided as a platform as a service from the cloud. Yeah, so that's our current state, and we want to move in this direction further. Yeah, we have API management platform, data sharing platform. Sorry, I need to go through. Yeah, maybe some words about software building blocks, which is really important when you are building. As one of previous speakers said, it's not only about hosting, it's about developer experience. And if you don't provide an easy way for new application to just connect and start using identity and access management, or to start just sending, reusing the templates, UI templating, or translating engine which we have, so that since we are working in multi-language setup, you need to be able to easily translate SMS or emails, and yeah. Also, sharing your APIs with end customers, because sometimes we have really big customers like, I don't know, Zublin, who uses thousands of trucks to build a new building, I don't know, Amazon Tower in Berlin, for example. Yeah, so that's very necessary part to have such set of blocks. And to do this, you really need not only DevOps engineers. So DevOps will not provide this. You need also software engineers and software development teams who work and dedicated on these platform services. So currently in our setup, we have 2 DevOps teams, or DevOps focus teams. Half of engineers were software engineers in the past, but switched to DevOps. And we have 2 platform teams who provide an identity and access management and the API management tools. Yeah, I think that's it. Maybe what's next? As I said, we want to extend our personas. We want to integrate different platforms, which I have shown in one user experience. Improve software building blocks, and yeah, make ready to be used by non-software developers. Thanks a lot.